All right, guys, so today what we will do is we're gonna continue with what we discussed last time, right? And we were talking about this example. And essentially what we did is we constructed the position versus time, velocity versus time, and also acceleration versus time. And then finally, we put also the acceleration as a function of the position. Did you guys have any other questions on this example? Okay. If not, we're gonna continue and let's actually start a new topic, basically, which is curvilinear motion. But before we do that, I actually have a few questions for you guys. So can you, for example, have a negative acceleration, right? So the acceleration would be below zero, right? But you would actually have a positive velocity. Is that possible?
Yes, doctor.
Yes.
Okay, how? How is that possible?
Let's say your velocity is 10 meters per second, but your acceleration is like -1 meters per second squared.
Okay, can you give me like a real life example of it?
So if your car is going 50 miles per hour, then you're slowing down. The acceleration is negative, but the velocity is positive.
That's right. Yes, exactly. So this is one example, right? How about could you actually have a positive acceleration, right? But the velocity would be negative. Is that possible too? Could that be possible? Like to have a positive acceleration, right? You know, meaning the velocity is increasing, but the velocity is negative. Is that possible?
Yes.
Yes, of course, yes, right? Yes, because basically the acceleration is positive, meaning that the velocity is increasing, but the velocity could be like, you know, -20, but then it's increasing. So -20, -19, etc. Like you could think of it as like, you know, obviously a car going backward, right? But you're you're accelerating basically. Okay, very good. That is very good. I actually have one more question. Can you actually have the velocity to be constant, okay, but the acceleration to be positive? Is that possible?
No.
What do you guys think? Is that possible? Why no? Why yes or why no? Can someone I think I have something in the chat, so let me see if I...
دكتور ما حسب شو صاير بالتراجكتوري تبع الاوبجكت، يعني يمكن تكون بي طلعت ونزلت وعملت وكله رجعت صارت equal في زيرو.
Right. No, I'm saying like if there is a constant velocity as a function of time, right? So your velocity is not changing.
Then A equals zero.
Then A is equal to zero, right? Do you guys all agree? Do you guys all agree? Okay.
Yes.
A is equal to dv over dt. Yeah, someone has told me A is equal to dv over dt. So if your velocity is v0, then A is equal to dv over dt, right? Time is growing, the velocity is not changing, therefore your acceleration is zero, okay? Okay, well, let's take an example. Like if a particle is going along a circle, right? If a particle is going along a circle with a constant velocity, will it have any acceleration?
Yes, doctor.
Why?
It has acceleration towards the center always because it's changing direction. I mean.
Yeah, but so how come like a particle could have a constant velocity yet it could have an acceleration? I'm gonna tell you why, guys.
Normal acceleration.
Yeah, but why? What's normal acceleration? Let me tell you why. The reason is the acceleration is actually the derivative of the velocity vector, right? So the velocity as a vector, right? Even though the magnitude of that vector is not changing, right? But the direction of that vector is changing, right? So if the velocity vector is simply changing direction, you will actually have an acceleration, right? The only time or the only instance where your acceleration, where if the velocity is constant, you would get a zero acceleration is if the velocity is going along a straight line. Basically, you're going along a straight line. Basically, your velocity vector is not changing, right? And the magnitude of it is not changing. So it's v0, v0 basically. Obviously, here dv dt v0, right? So you would have an acceleration if your velocity vector is changing. And in the case of a circle, right, even though the magnitude of that vector is v0, right, but in reality, right, if I actually move a little bit over here, then this is going to be my new velocity after like a very tiny amount, right? And my dv is actually this guy, right? This is my dv, and then that dv basically will be actually pointing toward the circle, right? And then later on, we're going to actually look into that, and then obviously an is going to be equal to v squared over r. Okay, so this is what I want you guys to know, is that the acceleration is actually the derivative of the velocity vector. So even though the magnitude of that velocity vector is constant, right, the actual acceleration may not be constant because there is a vector that could be changing direction, right? And then we can look into it. Okay, very good. Okay, so in this topic now, we're going to look into curvilinear motion. We're going to look into, parabolic motion and projectile motion. Okay. So what we will do as part of the study, basically, we're going to study projectile motion, and we're going to basically study the motion of a particle that is subject to some initial velocity, right? What would be its x position as a function of time, and what about its y position as a function of time? And when you have time, when you have x as a function of time and y as a function of time, you can extract t, and then you can kind of write y as a function of x. And ultimately, you will probably see that the motion of any projectile is actually a parabolic, right? It's a parabola. So when you actually throw an object, right, it will always basically follow a parabola, right? Whether you have like, a water, a water nozzle, basically anything that you basically throw will actually follow a projectile movement. Okay, regarding the position, basically, we're gonna look into like different frames for expressing position. And the first thing that we're gonna look into basically is the Cartesian frame. So if you have a Cartesian frame, basically, we can express the position of any particle. Let's say you have like, x0, y0, and then z0, right? And if the particle p is somewhere here, basically I can write this r, right? So r as a function of time, right? So r as a function of time is going to be equal to x of t I, right? Plus y of t j plus z of t k, right? So I'm writing right now my position of that point p as a function of time. So I, j, k are constant, basically, they are not changing. Although later on, we will actually have a frame where I can actually vary as a function of time. This unit vector can also vary as a function, etc. So this is my position as a function of time, right? Let's say this particle is actually kind of like going along this path, right? We know the velocity, right, is going to be equal to what? dr t over dt, right? So you are basically differentiating the vector of the position, right? And here basically you do the chain rule of differentiation. So I is constant, so basically it will be just x prime, right? And here we're providing you x as a function of time. So can someone tell me what would be the derivative of this vector?
Derivative of each one?
Exactly, take the derivative of each one, right? So it's very simple. So in this case, it would be what? X prime as a function of t, right? I plus y prime as a function of t j plus z prime as a function of tk. Okay, now what is x prime of t? X prime of t is nothing but your velocity in the x direction, right? Plus y prime of t is your velocity in the y direction. And then what is the last one is vz as function. If I ask you now, what is the magnitude of the velocity vector? Can someone tell me how can I find that velocity?
Square root of vx squared.
Bravo, exactly. So you take the square root of all of them, right? So it's going to be equal to vx squared plus vy squared plus vz squared. Okay, guys, is that all clear? Okay, all right. So now let us look into that on our lecture notes, basically. So the velocity will always be tangent to the movement, right? So no matter, whatever your movement is, basically your velocity vector will always be tangent to the path, right? If you know your path, right, then your velocity will always be tangent to that path. Okay, how about the acceleration? Is the acceleration tangent or no? So the acceleration, right, it will have two components. One component is going to be tangent to the path that we call tangential acceleration. And then it will also have a normal component, which is going to be perpendicular to the motion, right? And then that has to do with the fact that your velocity vector is changing direction. We're going to actually look into more detail into this later. But again, right, the acceleration will have two components. Why? Because the acceleration is basically the rate of change of the velocity vector, right? And that velocity vector might be kind of like increasing or decreasing along the trajectory, right? But again, it will also be changing direction. So we'll actually have two components for this acceleration vector, okay? Okay, so here, this is what I just wrote. So basically, if you have a curve or if you have a particle that is traveling along trajectory, you can basically express that as a function of time. Just 1 second. Okay, guys, sorry about that. So just like what I mentioned, so if you have a particle going along a straight path, basically, we can express basically x as a function of time, y as a function of time, and z as a function of time, right? And when you have basically x, y, and z as a function of time, you can get basically the two components of your velocity vector, right? And then you can find the magnitude basically simply using the Pythagorean rule, basically, by squaring square root of x squared plus y squared plus z squared. Okay, very good. So, yes.
ار اوف تي نحن ما نجيبها ولا بتكون عاطينا اياها؟
R of t, yeah, I mean, yes, of course, that would be given to you.
اوكي.
Okay, so obviously you need to actually have the position function of time, right, to be able to get the velocity and then find the acceleration. Okay, how about the acceleration? So let's say, I gave you, right, that velocity as a function of time. How can you get the acceleration on that object?
velocity.
Yeah, exactly. So now you can do A is equal to dv dt. And then guys, here we're doing like the first principles, right? So like A is equal to dv over dt always applies, right? So you have your velocity vector is given to you that way. And you have Vx as a function of time, Vy as a function of time, and Vz as a function of time. Then you end up with what? Simply Axi plus Ayj plus Azk, okay? What happens if, like, let's say I was as a function of time, how would that change? You would do basically chain rule on that, right? So it would be Vxt prime times I plus I prime of t times Vx. At some point, basically, we're going to do something where basically your unit vectors will actually rotate, right? So we'll actually look into that. But what you should know basically right now is, this is your velocity as a function of time. This is your acceleration as a function of time. And obviously the magnitude of the acceleration is going to be either the square root of ax squared plus ay squared plus z squared. Okay. All right, guys. So I think, yeah, so this is your velocity. We just described that. And then, yep, so that is it. And then that is your acceleration. Okay. So this is called Cartesian coordinates. All right. When you are talking about Cartesian coordinates, basically it means that these frames are basically the base frame basically is constant, and you're dealing with x, y, z. That is usually what we mean by Cartesian frame. All right. Okay. Good. So let us do this example here. Example 6. We have the velocity of a particle, right? Is given to you as, so v is equal to how much? So v as a function of time is equal to 16t squared. Okay. Yes.
The connection keeps lagging. I don't know if it's from me or you.
It's from her. It's from.
I can't see anything.
Are you guys able to see this well?
Yes, we are.
Is this lecture being?
Yeah, the lecture is recorded, but the other students are saying that they are viewing this fine. So it might be on your end. Okay.
I didn't hear anything.
Yeah. Yeah, try reconnecting back.
Is it doing?
Yeah,
Oh,
this
it's
is
being
recorded.
recorded.
Yes, yes, it is recorded.
I'm gonna try leaving and then reconnecting back.
Okay, all right, so if the particle is at origin when t is equal to 0, right, we need to find the magnitude of the particle's acceleration when t is equal to 2 seconds. Also, what is the x, y, z coordinates of the particle at that instant, right? Okay, so we know that the particle basically is at origin when t is equal to 0. We need to find its acceleration when t is equal to 2 seconds. How can I find the acceleration, right, at 2 seconds? Can someone help me out with that?
بعمل derivative للفي اول شيء اجيب الاي in terms of t.
Exactly. Yes. مظبوط. So
I.
yes, exactly. So you're gonna do 32 ti.
Yes, plus 12 t squared.
Plus 3 times 4 is 12 t squared j plus what is the derivative?
5k.
5k exactly. So a as a function a at time 2 seconds, it's gonna be 32 times 264 I plus 12 times 4 is how much? 48, right? 48j plus 5k, مظبوط, and that is in meter per second squared. So if you want to actually get the absolute value of that, it would be the square root of all of these, right? Plus 48 square plus 5 square. Okay, deal? How about the position? How can I get the position?
بعمل أول شيء integral للv.
Exactly. So okay, remember. So here we're actually doing this r, right? R is equal to what? V dt, مظبوط, from 0 to some time t. Okay. But remember, when you are doing this, basically, you have to add r at time 0, right? You guys agree? Because v is equal to dr over dt, right? So when you are integrating r, basically, you still have to add r at time 0. Okay, so that basically, v is equal to dr dt, right? So dr is equal to
Doctor, we said that R0 فينا دغري نحط 0 لأنه قالوا لنا إنه the particle is at the origin when t equals 0.
Exactly. Yeah, but I just want you guys to know about the overall approach, right? So here,
Okay, yes.
right, R0 to like r as a function of time, and then 0 to time t. Okay, so what is the integration of the velocity as a function of time? Basically, you will simply integrate that guy, right? So the integration of this guy is 16 t cubed over 3 I plus 4 t4 over 4j plus what is the integration of 5t plus 2? So it's going to be 5t squared over 2 plus 2t, right? And that is your r. Okay. Exactly. So in that case, you will simply replace that by r of 2 seconds. Okay. So it's going to be 16 2 to the power 3 is 8 over 3 I plus 4 times 2 to the power 4 is how much? 2 times 2 is 4 times 2, 8 times 2, 16 over 4j plus 2 squared is 4 over 2 is 2 times 5 is 10. So 10 plus 4k. Okay, so that is your position. So that simply tells you that at time 2, مظبوط, you are at whatever this value meter in the I direction, you are at this value in the J direction, and then you are at this value in the K direction. All right, pretty basic. Okay, very good. So let's jump into another example. And here, basically, the velocity of a particle is given to you as v is equal to, let's do it here. So your velocity now is equal to 3I plus 6 minus tj meter per second. We need to find the displacement of the particle during the time interval t is equal to 1 to t is equal to 3, right? So you have v is equal to 3I plus 6 minus 2j. Okay. So if I gave you the velocity, okay, I need to know how much displacement has a particle traveled between t is equal to 1 to t is equal to 3 seconds. How can you guys solve that?
It's the integral between 1 and 3 of the velocity.
Yes, exactly. Are you guys all clear on that? Like, the rest of the people who are watching this, is that clear? Like, anyone has questions?
Yes, doctor.
Okay, very good. So basically, you will integrate that, right? So here you are saying that r is equal to v dt, right? T is equal to 1 to t is equal to 3 seconds, right? What is the integration of the velocity? In this case, it's going to be 3ti plus 6t minus 2t is t squared, right? J, and then you're integrating this guy from t is equal to 1 to t is equal to 3, right? Or in other words, r is equal to r of 3 seconds minus r of 1 second, right? So it's going to be, you're going to do the first one first. So 3 times 3i plus 6 times 3 minus 9 j. So this is the first term minus out of 1 second, which is how much? So 3i plus 6 minus 1 j. Okay, so this is basically that, and then this is that. So then you want to basically have I and then I. So you want to do like I. So 9 minus 3, right? Plus j. Yeah, do this. So 6 times 18, 6 times 3 is 18 minus 9 is 9. Minus 6 minus 1 is 5 minus 5, right? So it's going to be equal to how much? I9 minus 3 is 6. So 6i plus 4j, okay? So this is your kind of like your delta R. As well, this is basically the displacement that has done. So this is more like delta R, right? Okay, so this is basically when you are integrating, right, the velocity between t1 and then t is equal to 3, right? Basically, you are finding the difference in the displacement. Okay, does it make sense, guys? So this is how we are doing that. Okay, this is basically delta.
Doctor, I have a question.
Yep.
So here we didn't put r of 0 because r of 0 is equal to 0 as a constant integration.
Basically, in this case, we don't really need to use r is equal to 0 and t is equal to 0. Basically, you have your velocity, right? And we want to basically find, we don't really care if r is equal to 0 or t equal to 0, right? Here, basically, all that you are doing, basically, you are integrating this guy. So whatever constant that you would actually have, it will actually be subtracted, Mazboot, because you're only looking at the difference between the displacement between time is equal to 1 to time is equal to 3. If you actually had some constant, it will actually cancel out here because it will be carried between this guy and then this guy, right? So the constant will actually disappear because you're subtracting that position, right? Remember, here you're kind of integrating the velocity, right? So you're finding how much position, right, you have developed between time is equal to 1 to time is equal to 3, right? If you want to find the absolute velocity vector, then you're going to integrate this guy from 0 to whatever t, Mazboot. If you do this, you will basically be finding the position of the particle, right, from 0, right? In that case, obviously, you would basically add here r of 0. Okay, let me just do this one more time just to kind of clarify this for you guys. So if I have some, velocity vector, right? So you have vxi plus vyj plus vzk, right? I know that the velocity is actually equal to dr over dt, right? As a first principle. So what is my dr? Dr is equal to v times dt, okay? So if I integrate this guy, right? If you start from time is equal to 0, right? Then, and you start from time is equal to 0 to this time t, then here r, you want to start r of 0, right? That corresponds with that time, right? And then here it would be r of t. Okay, doing this integration, you're going to end up with r of t, which is obviously a vector, minus r of 0 is going to be equal to the integration of v dt 0 to time t, right? So r of t will be equal to 0 to t v dt plus r of 0. Okay, in the case that we're doing right now, basically we're only interested in finding the difference we're basically interested in finding this guy, right? This whole term from some time t to from time t1 to time is equal to 3 seconds. So you'll just do that. Okay. Yes, someone is asking if the lecture is recorded. Yes, the lecture is recorded. Okay, guys, very good. So, so overall, Cartesian coordinates is really some of the simplest, right? In that case, basically, just like what we said, basically you would have particle is given to you as a function of time, right? You have X, Y, Z. It's like you have a radar station, right? And then you have some aircraft coming up, right? You can measure its X as a function of time, you measure its Y as a function of time, and then Z as a function of time. And then you can use these guys to predict the plane's velocity and also the plane's acceleration, right? Based on that reference frame. Okay, let's do now projectile movement. And I'm gonna do this actually here now so I can kind of illustrate that in a very simple manner. Let's do this. Okay. Okay, projectile motion. So if you have an object, okay, that you throw with some velocity vector, right? You throw with like a velocity v0. I would like to be able to predict where this guy is going to be. Okay, before we actually do that, we want to look into the acceleration of that object, right? And then we're going to integrate the accelerations to find the velocities, and then we're going to integrate the velocities one more time to be able to find the position. But how do we actually find the acceleration of the object? Can someone tell me how can you find the acceleration of an object? How do you find, what would be the acceleration of an object, let's say free falling?
Gravity.
Exactly, you want to use the gravity, or you want to use, exactly, or you want to use the forces, right? So in this course, basically, what we're going to do is we're going to put basically the forces on one figure, okay? And I'm going to make that figure, I'm going to call it external, remember, external forces, okay? And that figure actually has to be equal to, we're going to call them inertial forces. Basically, you're saying here F is equal to MA. All right. So we're basically going to use that figure to be able to find the acceleration. Okay. So I'm going to draw the same object, right, on the two figures, right? And here, let's remove this velocity because we're not putting the velocities. We're only putting the forces here, right? What would be the force applied on this object?
The force of gravity, which is downwards.
Exactly. So you want to put basically which is equal to what?
G.
G or mg?
The
mg, okay?
oh yes, mg. Sorry.
Okay, guys. Remember, in this course, always the gravity will never be an acceleration, right? It will always be the force of gravity is always equal to mg, okay? Okay. How about on this diagram? What are the accelerations? Here, basically, it's more like a vector, right? What are the accelerations? Well, we don't know the accelerations yet, so we're gonna assume that this object have an acceleration in x direction, max, all right? And I'm gonna say it has may. Okay, so I have on this frame basically, let's put x and then y. Okay, so I have max is my acceleration in x direction, may is acceleration in y direction. How can I find max? Basically, I'm going to use this, right? So to find max, what I'll do is I'm going to sum the forces. So guys, pay attention to this very, very carefully. So I'm summing the forces, right? So I'm going to indicate the direction about which I'm going to sum the forces. So I'm going to sum the forces. This is left to right is my positive direction. And I'm going to do, what are the forces that are from left to right in this case? There are no forces, right? Zero, right? Okay, now I want to move the second figure. What are the inertial accelerations on this diagram is going to be equal to max. Okay, so what is ax? Zero, okay? So I have no acceleration in x direction. Why? Because I simply have no force in x direction. Okay, so now let's look at, we're going to sum the forces in the y direction. And we're going to do this literally, guys, for all the course, really, same approach. So summing the forces in the y direction, and I'm assuming that, you know, going upward is my positive direction. What should I write here?
mg equal
Minus
may.
Is it mg or minus mg?
Minus mg.
Minus mg, exactly. Remember, guys, what you do on that figure, you're going to do on that figure. So it's going to be minus mg, it's going to be equal to what?
may يعني g equal minus g equal ay.
لا نحن we just want to find a, right? So ay is going to be equal to what?
Minus g.
Minus g, okay? Okay, very good. So now we used the forces and we found the accelerations. Now we have the accelerations. We can use kinematics to find the velocity in x direction. and the position of x direction as a function of time, and then we're going to use the acceleration in the y direction to be able to find the velocity in the y direction as a function of time, and also the position in the y direction as a function of time. Okay, is that okay, deal? Okay, so how can I find the position, I'm sorry, the velocity in the x direction based on this? So I know, so ax is equal to 0, right? What would be my vx?
Constant.
Exactly, so vx is going to be ax dt from 0 times t plus your velocity in the x direction. مظبوط? Not the velocity, the initial velocity in the x direction. Or vx 0. You guys agree? So ax is 0, so your velocity of a projectile in x direction will be equal to vx 0. Right? Let's say the projectile usually is given to you as v0 like that, and then it will actually give you a theta. Then what would be your velocity in x direction? What would be this component?
v0x v0y عنه يكون.
مظبوط اللي هي v0 cosine theta ما هيك in x direction.
ما v0 sin theta هذه.
v0 sin theta, right? So my velocity in x direction is going to be equal to v0 cosine theta, right? How about my x in x as a function of time? How can I find that?
يعني v0 cosine theta times t.
You're going to integrate that, right? But let's actually write the equation. So vx dt, right? Plus x at time 0, right? What would be the integration of vx dt? It will be v0
cosine theta times t.
Times t, right? Let's say if x0 is 0, then it's set. So this is my x as a function of time. Now let us look at our velocity in the y direction. What is my ay? Is equal to how much?
Minus g.
Minus g, right? Okay, very good. So let's find our velocity in the y direction. How can I find the velocity in the y direction?
Minus gt plus v0.
Ay dt, right? From 0 to t. It will be equal to how much? Minus t plus
minus
what?
gt plus v0. v0y, sorry.
Yeah,
v0 sin theta.
v0 sin theta. So you're looking here at the initial velocity in the y direction. So plus v0 sin theta. Okay. Now, if I want to find my position as a function of time, I'm going to integrate this guy, right? Which I already have. Integrating vy dt, right? 0 to times to t plus y of 0, right? So that is equal to how much you're integrating this guy, minus gt plus v0 sin theta dt from 0 to times t. Okay? Plus y of 0, let's say it's 0. Like basically you're starting from the origin. Okay, can I do this? Can someone help me out with this? What is y of t?
Yes, minus gt squared over 2 plus v0 sin theta times t.
And that's it.
Oh,
right?
that's y0 equals 0.
Okay, very good. So now we actually have that. All right, so very good. So basically, guys, this is the equation of a projectile, right? What would be the velocity of the projectile in the x direction? It's constant, okay? But the velocity of a projectile in a y direction is actually changing, right? Let's look actually at this figure right here, right? So this is the motion of a projectile. If you actually throw the ball with some velocity, what is actually happening to the velocity in x direction? It's constant, right? So basically you're taking these at equal time, right? So at equal time, basically, right, you move by the same amount all the time. So if projectile in x direction will actually have a constant velocity, so it will actually have a constant velocity, but in y direction, the velocity is doing what? The velocity is increasing, right? What is v0 in this case here? V0 is, what is theta in this case? Theta is 0, مظبوط. So sine 0 is 0, so your velocity is equal to minus gt. So here you can see the velocity in y direction is actually increasing proportionally, right? As you are going down, your velocity is increasing. So vy is equal to how much? In this case, what is the velocity in the y direction?
أي case, doctor. مش هاي اللي عنا هون جمهور.
Here, I'm looking at this figure.
Minus JT.
Minus GT, exactly. So your velocity here is minus GT. Why minus?
If we take no positive upwards.
Exactly, right? So here your velocity is equal to minus 9.8 times t, right? So why is it negative? Because we assumed here right? That my y is positive. I assume my acceleration initially is positive, right? So if acceleration is positive in that direction, my velocity is positive in this direction, and then obviously my y is positive in this direction. Okay, so that is why we actually have the minus sign, right? So the absolute value obviously will be gt. Okay, let's do, yeah.
بس سؤال صغير يمكن شرحتها هلا بس نسيت اجي اسالك عنها. ليش بس عملنا انتجرال from 1 to 3 seconds بالاكزامبل اللي قبلها تبع الار ما حطينا plus r1 of t؟
Because when you're integrating, basically, you're only doing the boundary, right? When you're integrating the position, when you actually have the boundaries from 1 to 2, then you don't need to know the boundary at 0, right? You will just simply do the difference.
اوكي بس يكون عندي بس تكون بس مبلش من الانيشال بوزيشن من الاوريجن بوزيشن بس بحط بلس r0 او x0 او y0 اللي او
Exactly.
اللي هي
Yes, exactly.
اوكي.
Okay, guys. I think, guys, this session is gonna end up soon, so I'm gonna close it now, and then we're gonna talk for a few more minutes on doing like one example on this, and we're gonna be done. Okay. So I'm gonna close this meeting and then restart it.